What's up, everybody? He loves Lays. It's Professor J, back at it again with another math video. Today's lesson topic is the greatest common factor, and I'll be explaining a bit of basic info, how to avoid some common mistakes, and solving a variety of GCF questions. First, I'll be discussing a bit of basic information, but let's give a warm welcome for our guest, Billy! So, Billy, what brings you here?
Well, I couldn't do my math homework, and I was hoping that you could help me.
Well, okay, Billy. Just sit back, relax, and I'll instantly solve all your math problems.
Alright, great.
Okay, first, Billy, did you know that factors are whole numbers that could be multiplied together to get a given number? And also, factorization is when you're dividing a whole number into its prime and composite factors.
Wow, I never knew that. Keep going.
Okay, Billy. Did you know that the GCF is the greatest common factor that can be equally divided into a set of given values?
Okay, wait, just give me a little time to jot that down.
Okay, go. A prime number is a whole number with exactly two factors, one in itself. And last but not least, a composite number is a whole number with three or more factors, one itself, etc.
Wow, thanks for all your help, Professor J. I'll be heading home now.
Man, did I love Billy. Anyways, now I'll be giving you a step-by-step explanation of how to calculate the GCF. Method 1. First, I would factor both numbers using a factor tree until you have prime factors. That's when you know you're done factoring. Step 2. Multiply both prime factors each number has in common. If there aren't any common prime factors, the GCF is 1. Method 2. First, list all factors of each number in the set from least to greatest, and it could be more than 2 numbers. Second, start looking for the GCF from the right side until you find it. For example, if a question said, find the GCF of 18 and 6, you could do method 1. And then you would factor 18, right? And then you would factor 6. And then you would circle the prime factors each number has in common. And then you would multiply those prime factors, and then you would get your GCF. If you were to do method 2, then you would list all the prime factors of each number from least to greatest. And then you would circle the greatest common factor, and then that would be your GCF. Now that you know how to calculate the GCF, we're going to go through a few common mistakes and how to avoid them. So everyone makes these common mistakes, one being that people often don't know when a number is composite or prime. The second mistake is that they use/multiply all prime factors of each number. The third one is that they often add the prime numbers instead of multiplying them, which will give you the wrong answer. And the last one is that they continue to factor the prime numbers. How do we avoid these common mistakes? Well, for common mistake number 1, you have to use the divisibility rules and identify any other numbers that are divisible by that number. Number 2, only use/multiply the common prime factors of each number. Number 3, instead of adding the prime factors, multiply them. And number 4, when you factor a set of given numbers into its prime factors, don't continue to factor. So now that you know some basic info, how to find the GCF, and how to avoid some common mistakes, let's do a SAT-related word problem. First, we have to underline the key information, which is this, as much as possible in the question. Then we would make a list of this important information. And since the question said they want to sell an equal amount of both snacks but as much as possible, that means we have to find the GCF. Now there are 2 methods you could do for this. You do method 1, which is you would factor 54 and 36 until you have prime factors. So 9, 6, 3, 3, 2, 3, 9, 4, 3, 2, 2. Then I would circle the prime factors each number has in common, which is 3, 3, 3, 3, 2, and 2. Then I would create a GCF equation where I would multiply the common prime factors together, which is 3, 3, and 2. So then 9 times 2. And then therefore the GCF is 18. Another method you could do is by just simply listing the factors of each number from least to greatest. So 1, 2, 3, 6, 9, 18, 27, 54. Then 36. 1, 2, 3, 4, 6, 9. 12, 6. So then I would circle the greatest common factor, which is 18. Therefore, the GCF equals 18. Oh, shoot. So now this solve question is a bit more challenging since the numbers are larger, but still we'll do the same method. So method 1, 252, 326, 23, 76, 23, 78, 6, 13, 23. And then now I would circle the prime factors each number has in common, which is 2, 2, 3, and 3. Then same thing, create a GCF equation, multiplying these prime factors together. So 2 times 3, and then therefore GCF is 6. And then same thing for method 2, just list the factors from least to greatest, and then find the greatest common factor, which is 6. So now we're switching things up a bit with a multiple choice question. What's the GCF of 18, 24, and 36? So for this question, I'm just going to do method 1. So factor 18, 6, 3, 2, 3, factor 24, and 36. So then I will circle the common prime factors of each number, which is 2, 2, 2, just got 3, 3, 3, and I believe that's it. Yep. Then create a GCF equation, multiplying these prime factors together. 2 times 3 equals 6. Therefore, the GCF is 6. So then the multiple choice question, we would answer number 2. Alright, so fill in the blank for the GCF of 24 and 56. Well, first, 24 divided by 4 is 6. And then, of course, 6 divided by 3 is 2. And then 4 divided by 2 is 2. And for 56, 56 divided by 8 is 7. And then 8 divided by 4 is 2. And 4 divided by 2 is 2. So then, we would circle the prime factors each number has in common, which is 2, 2, and 2. So that can be expressed as 2 to the power of 3. So the GCF equals 2 times 2 times 2, right? Because I'm multiplying the prime factors together. And then therefore the GCF is 8. Last but not least, we're going to be moving on and solving some GCF word problems. But for these word problems, I'm only going to be using method 1. Bob and Rohan went shopping at Centra. Bob bought one package of 64 guava candies, and Rohan bought 88 individual Lay chips. Wish I could have been there. They both wanted to have the greatest equal amount of each snack, so they decided to share. How many guavas and Lays does each person receive? So first, I would underline the key information, which is 64, 88. They both want to have the greatest equal amount, and how and equals in each person will see. Then I would make a list of this information. So 64. And since the question said they both wanted to have the greatest equal amount, that indicates that we have to find the GCF. So method 1. First, we're going to have to factor 64 and 88. So 16, 4, 2, 2, 8, 2, 4, 2, 2, 2. And 88 would be 8, 11. 4, 2, 2, 2. Then I would circle the prime factors both numbers have in common, which is 2, 2, 2, 2, 2, and 2. So then I would create a GCF equation where I would multiply 2 times 2 times 2, which is also 2 to the power of 3, which equals 8. And then I would have to write a therefore statement afterwards. So therefore, the GCF equals 8. GCF word problem number 2. Feel free to pause the video whenever you want if you want to solve any of my questions. While reading this word problem, I'm going to be underlining the key information. So 3 professional hockey players went on a morning run and brought their fitness trackers with them. One player ran 850 meters, another player ran 625 meters, and the last player ran 1,075 meters. They all wanted to run the same distance tomorrow. What is the greatest distance in meters they run the next day? Now, I'm going to be making a list, and by making a list, it keeps me more organized. I know the numbers I'm dealing with, and I'm basically making a plan and executing it when I solve the question. So, 1,075 players, and greatest equal distance. That means we're going to have to find the GCF. So I'm only going to be doing method 1 for this question, which is factorizing those 3 numbers. So 850, 85, 10, 517, 625, 5, 25, 5, and 1,075, 25, 43, 5. And now we're going to circle the prime factors each number has in common. So 5, 5, 5, 5, 5, 5, and I believe that's it. So then we create a GCF equation where we multiply these prime factors together. So 5 times 5, and the GCF is 25. And whenever we have whenever we're solving a word problem, we always have to write a therefore statement. So therefore, the GCF equals 25. And here's your answer key. Feel free to pause the video to see if your answers were correct. Resource page. My learning website was Helping with Math if you ever want to learn more about GCF. My game website was Math Playground, and my practice website is iExcel. And joke of the day, why are obtuse angles so depressed? Because they're never right, huh? Thanks for listening. Don't forget to subscribe to 602 SAC Math Tutorials to learn more about GCF.